Okay, Year 11, we're going to continue with those notes from the other day. First example here we're going to look at in this lesson is functions given by p of x equals x minus 1 on 3, where x is 1, 2, or 3, is a function of probability distribution. Now, remember, one of the features of a probability distribution is that the sum of the probabilities is 1. So let's work out what p of 1 is first. P of 1 is 1 minus 1 on 3, which is 0 on 3, which is obviously 0. And P of 2 is 2 minus 1 on 3, which is 1 on 3. And then P of 3 is 3 minus 1 on 3, which is 2/3. Now when I work out the sum of the probabilities for each outcome, sorry, I made a mistake there. It should be P of 1, of course. P of 1 plus P of 2 plus P of 3, that's just equal to 0 plus 1/3 plus 2/3, which is equal to 1. So therefore, I can say P of x is a probability distribution. Okay, copy that down. Let's look at the next one. Now, oops, I've already done this one for you, but hide that. Okay, do it from scratch. Okay, all right. Now, this question says, find the value of n for which the table below is a discrete probability distribution. Okay, so that means the sum of the probabilities has to be 1. So we're just going to find a 12th plus a 6th plus 5 over 12 plus 1 over 12 plus n equals 1. Okay, so that's going to be 1/12, 2/12, 3, 8, 9/12. So 9/12 plus n is equal to 1. And then n must be 3/12 or 1/4. Okay, I'll write that down and copy it down. Now let's have a look at the next question. Game involves scoring points for selecting a card at random from a deck of 52 cards. The table shows the scores awarded for different selections. So you get a score of 2 if you get a number 2 to 10. You score of 5 if you get a picture card, which is a jack, queen, or king. You get a score of 8 if you choose ace. Now, it says draw a probability distribution for random variable y. So we're going to put little y. Let's get rid of that line there for a minute. We're going to put little y here, and then because it's a probability distribution, you must have P for probability, capital P, capital Y equals little y, close bracket. Okay, now, what are the values we're looking at? Well, first value we're looking at is 2. Now, what's the probability of choosing a 2? Well, just remember that there is 4 of each type of card. So if I'm looking at the numbers from 2 to 10, so 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, each one of those cards, there are 4 of them. So there are 4 2s. There are 4 3s. All the way to there are 4 10s. Okay, so altogether, there are 36 cards numbered 2 to 10. Okay, so the probability will be 36 out of a possible 52 cards. Now, what about a score of 5? Okay, for a score of 5, well, there's, for a picture card, there's 4 jacks, 4 queens, and 4 kings. So altogether, that's going to be 12 out of 52. Okay. Now, what about a score of 8? Well, there's 4 aces. That's 4 out of 52. And yes, you could simplify those fractions if you wanted to. Okay, so there's a probability distribution table. Copy that down. And we can answer the questions. Now, probability of y less than 8 means that you're looking at getting a score of 2 or a score of 5. Okay, so that means you're going to have 36 on 52 plus 12 on 52, which equals 48 on 52. And if you simplify that, you're going to get 12 on 13. Okay, now what about probability is y is bigger than 2? Okay, now, so bigger than 2 means I'm getting a score of a 5 or an 8. So that means the probability that my score is 5 or probability that my score is an 8. Okay, so that's going to be 12 on 52 plus 4 on 52, which equals 16 on 52. And that will simplify to 4 on 13. Okay, copy that down. Now, let's have a look at this one. We're going to draw a probability distribution table for the number of black balls that can be drawn out of a bag containing 5 blacks and 3 whites. Okay, so let's draw a little picture. We've got some sort of box, and I've got 5 blacks, and I've got 3 whites. Now, I want you to draw a probability distribution table. So let's do that up here. So do my table reasonably large. Now, let's use a random variable of x. So I'm going to use little x here. Draw that line across. And then the probability of capital X is my random variable equals x. Okay. Now, what are the possibilities for the number of black balls? Okay, because it's interested in the number of black balls. So the random variable is the number of black balls. So I might get 0 black balls on those 2 selections. I might get 1 black ball on the 2 selections. Or I could get 2 black balls from the 2 selections. So now I've just got to figure out what's the probability of 0 blacks. Well, the probability of 0 blacks will be working out the probability of 2 whites. So if I'm getting no blacks, I must be getting 2 whites. The 2 whites will be 3 over 8, because there's 8 altogether, times by, and I'm not putting the ball back once I take the first one out. So now I've got 2 whites, and that's 2 over 7 there, so that's 6 on 56. So 3 on 8 minus 2 on 7. That's going to give me 3 on 28 as a simplified fraction. Or you could leave it as 6 on 56. So 3 on 28. So there we go. So 3 on 28 is my first entry for the probability. Now, what about the probability of one black. Now, that means I'm either getting black first and white second, or I am getting white first and black second. Okay. Now, black first would be 5/8 times white. Now, there's 3 whites. There's 1 less, so that's 3/7. And or is plus. Now, first white will be, choosing white first would be 3/8, and then choosing black second would be 5/7. Now, what does that work out to be? If you put that into your calculator, you should get 15 on 28 there. So that goes here. 15 on 28. Okay. Now, what's the other option? 2 blacks. I've got space to do that here. I'll just do it here. So probability of black and then black on the second selection. Well, black on the first selection is 5/8, and is times, and black on the second selection will be 4 blacks out of 7. Okay, so 5/8 times 4/7, that goes to 5 on 14 as a simplified fraction. And I'll just put that in here, 5 on 14. Okay, so there's my probability distribution table for choosing the number of black balls out of that bag. Okay, copy that down, and now we're going to look at something called a uniform probability distribution. Now, uniform means the same. So if you've got a uniform probability distribution, that means the probability for each outcome is the same. All right, so that means the probability of x equals x is 1 on n for x equals 1, 2, 3 up to n. Okay, so classic case would be rolling a die. Each number on the die is equally likely to occur, so which is 1/6. So that's a uniform probability distribution. Now, what about first question? Let's look at tossing a coin. So tossing a coin, I get probability of heads is equal to 1/2. Probability of tails is equal to 1/2. Okay, so you can see that I've got the same probability for each outcome. All right. Now, because we're looking at in terms of what the way we write this down, I'll just change that. You can see it's going to be uniform, but in terms of the notation, what I should be doing, because we're looking at this in terms of random variable, we're going to say the random variable is x, where x is the number of heads. So that should be 0 heads and 1 head. Those are the two possibilities. So x is the number of heads. So what I should be writing down is the probability of 0 heads is 1/2. The probability of 1 head is 1/2. I know you could write down P of heads and P of tails as well. That's okay. But we've got to get used to using this notation here. All right. So you can tell there that it is a uniform. I could say therefore uniform probability distribution, because each probability is the same in this case. Now, what about number of heads when tossing 2 coins? Now, just for variety, we're going to draw a tree diagram. So the first coin could be heads or tails. If I get heads on the first coin, the second coin could be heads or tails. Or if I get tails on the first coin, the second coin could be heads or tails. So if you're looking into a sample space here, I've got 2 heads there, a head and a tail, and then a head, and then 2 tails. So if you're looking at the number of heads, well, the most number of heads I can get is 2. So if I'm going to use the random variable notation, what I'm going to do here is write down capital X for my random variable. So X is the number of heads. How many heads can I get? 0, 1, or 2. Okay. Now, let's work out the probability of no heads. So, probability of no heads, so little p. Well, it's not getting any heads, I'm getting 2 tails. That's a half times a half, isn't it? Okay, which is a quarter. Now, what about the probability of 1 head? Now, the probability of 1 head, let's just down here, p of 1, right? Probability of 1 head, that means I'm either getting heads, tails, or tails, heads. Okay, so now that means I'm getting the probability of heads, tails, or is plus capital P probability of tails, heads. Now just be aware that it's a little p at the beginning there, and these are capital P's after the equal sign. Now heads, tails, it's going to be a half times a half, which is a quarter, and tails, heads also a quarter, and that will equal a half. Okay, last of all, probability that I get, so little p, 2 heads. 2 heads will be a half times a half, won't it? Which is a quarter. Okay, now you can see here that the probabilities of the number of heads when tossing 2 coins is not the same, because I've got a quarter, and a half. So what I would say is the probabilities are not all the same. Okay, so the probabilities are not all the same. Which means not a uniform. Now that's the key word, not a uniform. Uniform means the same, not a uniform probability distribution. Okay, so that's the end of the video.